Hey guys, today's other lesson is called the Skittles Balancing Equations activity. I usually do Skittles with this activity, but because of DLI, I had to do it a little differently this year. But at any rate, your learning targets for this activity, I can count the amount of atoms in a molecule. I can use the law of conservation of matter to identify if a chemical reaction is balanced or not. So we're really going to start looking at what a chemical equation is and how do we kind of tweak some numbers around to make sure that we are abiding by the law of conservation of matter and that matter cannot be created or destroyed. So we have to have every atom accounted for. All right, so your first activity that you guys should have done today, and again, you guys might be at home doing this via DLI, or you guys might be sitting in class right now doing this. Either way, you guys should have done this as your bell ringer. This should already be done for you guys. And if you guys are sitting in my class right now, you need to have your laptops facing forward so you guys can pay attention as I go through these notes. Okay, so you guys should have opened your OneNote and added these into your notes. So here's our chemical reactions section, and then you should have added a page entitled it Chemical Equations. And then you guys will note that I added those two notes as well. Your guys' notebooks should be the same. Be prepared to show me this for a grade when I get back. Okay, so hopefully this is done, and if I were to go around and grade you guys as to whether or not you did this, it is there and ready for you to go. Okay, with that being said, I started off by writing a chemical equation at the top of my notes. You guys don't have to do that. I just wanted to show you what a simplified chemical equation looks like as I go through the features. At this point, if we're looking at our notes, you guys already know what a chemical reaction is. We've talked about that through Amplify. It's already in your key concepts. It's already in your notebook. We've also gone through the law of conservation of matter on our last lesson as well. Okay, so again, what I'm going to show you guys is this is a chemical equation. I'm going to talk about all the features. Okay, so you guys can kind of see the same equation right here, but it looks a lot messier. You guys can see that these large numbers in front are called the coefficient, and this should be familiar to you guys. If you haven't already, you need to go back and do the counting atoms assignment from Vigilante Friday and the Wednesday counting atoms Kahoot from last Wednesday's remote day. Those are going to help you with this. If you guys haven't done those, this might not make sense at all, but coefficient should be a word that you guys know from those two assignments. All right, so the big number in front of a molecule or an atom is called the coefficient, and it tells us how many molecules or atoms we have. Okay, so your guys' first little part of today's activity was the warm-up. You guys notice that some of these don't have coefficients in them. That means that they have only one molecule. These are all molecules here because they're made of more than one atom. Okay, so more than one atom or element, more than one atom or element. These have an imaginary coefficient of 1, meaning we only have one molecule of sodium acetate or barium chloride. Okay, versus these ones, you guys notice I now have a coefficient in front of them, so that means I have 3 molecules of sodium acetate. This one I have 2 molecules of barium chloride, so twice the fun. Okay, all right, back to the notes. The little teeny tiny number after the atoms is called the subscript. That tells us how many specific atoms we have for one molecule. So if we don't have a coefficient in front, we assume we have one molecule. That tells us how many atoms of each. So if we look at our reaction here, if we're just looking at one molecule of H2, let me circle that here, one molecule of H2, we have 2 hydrogen atoms there, okay? If we're looking at one molecule of O2, we have 2 oxygen atoms in that molecule. Okay, and if we're looking at just one molecule of water, we have 2 atoms of hydrogen, and even though there's not a number written after the oxygen, because we wrote the symbol for oxygen, that means there's at least 1 atom of oxygen there. Which those should be things you guys all know from now, because you guys know what water is and how that looks from other assignments and maybe just your previous knowledge. Okay. Sometimes we'll write the states of matter that these are in, so we know hydrogen is a gas, so we would put a little baby g after it. We know oxygen is a gas, so we'd put a little baby g after that, but we know that water is more commonly found in its liquid form, so we would put a little L after that. We're not going to worry too much about states of matter here. Okay, this arrow in the middle shows us that there's a chemical reaction taking place, so you guys might see it and refer to it as yield, so 2 hydrogen molecules plus 1 oxygen molecule yield 2 water molecules. You'll more often hear me say reacts to form then. instead. So 2 hydrogen molecules plus 1 oxygen molecule react to form 2 water molecules. So more often than not, I'll say react to form. So this arrow basically indicates there's a chemical reaction taking place and that we're forming some kind of product. Okay, all of your reactants go on your left-hand side. So we have 2 reactants here. We have hydrogen gas and oxygen gas. Those are our 2 reactants. And then all of our products go on the right-hand side of that arrow. Only thing we're producing here is water. And again, these should be kind of familiar to you guys because this isn't the first time you've seen the term reactants and products and kind of seen these things in play in a chemical equation. We just haven't called it a chemical equation yet. Okay, so those are the main things that I want you guys to know about what a chemical equation is. You guys can see in your notes that all those things are defined underneath this little drawing or this diagram for you guys. Okay, we're not going to go into too much of balancing equations, but here are the rules that you guys would use if you were to look and say, hey, this equation doesn't follow the law of conservation of matter. How can I fix it? These are your rules that you're going to go over, and we might utilize those a little bit later in this unit. And then here are just some examples of some reactions or equations that were not balanced, but then we balance them by changing the coefficients. Keep in mind that even though we might not be doing any balancing in here yet, that you guys can't change the subscripts. You can only change the coefficient. If you guys were to change like this hydrogen to make a 4, just so it balances out over here and follows the law of conservation of mass, you no longer have hydrogen gas. You have a completely different element. So that kind of just ties us back into the beginning of this unit where we talked about, you know, we have certain numbers of atoms, they're arranged differently, and that's why we have certain products. So if you guys change the number of atoms, you're probably also going to change how those atoms are arranged, and therefore they're going to be a different substance. They're going to be a different substance with different properties. So keep that in mind. That's basically it for your notes. We're going to jump back into this little lesson that we're doing today. So again, in your warm-up, you guys should have done some practice over counting atoms. You guys could either have used your draw tool to write your number of atoms for each of these, or you guys can click and type as well. If you guys haven't already done that, you guys need to catch up and get that done. Let the guest teacher know so she can pause this video and let you guys get the warm-up done. But again, you guys should have all of the atoms in each of these 2 molecules counted, these 2 molecules counted, and these 2 molecules counted. So if you need to, let the sub know, pause now, and take about 2 or 3 minutes to finish this part of your assignment. All right, moving on to the main part of this assignment. So your first activity is just a little notes review. You guys, again, should have those notes that we just went over in your notes. At this point, your guys' laptops are facing forward and you're paying attention. So you have 3 things that you need to do on this page. So you have 5 formulas of molecules. You are going to look at each of those formulas and highlight any of the subscripts pink. So show me what you understand about writing a chemical formula by highlighting all the substances pink. So the subscript, excuse me. So for instance, on oxygen, this 2 right here is a subscript, so I would highlight it pink, okay? Next one is highlight all of the coefficients orange. So remember, the coefficient is the large number that goes in front and tells you how many molecules they are. If we look at this one, 5 is a coefficient. It's in front of the H2. Really, this is a coefficient 2. It's an imaginary 1 in there. So if you wanted, you guys could kind of highlight that space. That's really up to you. You don't have to, though, because there's technically not a number written there. So there's technically not a coefficient. But it does tell us that there's 1 carbon dioxide molecule. So go ahead and highlight all of those coefficients orange. And then finally, you're going to circle any formulas that have more than 1 molecule. So for instance, because we highlighted this 5 and said it had a coefficient of 5, that means we have 5 molecules of H2 gas. So you guys would circle that one because we have more than 1. Okay, so that kind of covers those. At this point, you guys can go ahead, flip your computers around, pause this video, and finish slide 6. All right, moving on to our next slide, slide 7. This should be fairly easy for you guys. Your computers should all be facing forward right now. You guys have these 5 vocab terms, and then here you guys have a chemical equation. So you need to click and drag those vocab terms to the correct spot. So for instance, product is what's produced, so I would drag it over to this box and leave product right there. Okay? Go ahead, flip your guys' computers around, take about a minute or two to do this quick little activity on slide 7. Pause this video, and then we'll come back and move on once you're all done. Make sure you guys flip your computers back towards the front when you finish. All right, let's get to the beef of this assignment. So this is called the Skittles balancing activity. Again, usually I get to do this on paper, and since I have DLI kids, you guys can't use Skittles to do this. We're going to use the draw tool instead. Yay! All right, your directions. Use the draw tool to make a color key for each atom. That's the first thing you're going to do, and I'm going to do an example for you guys so you can see how it's done. Count the number of atoms for each molecule and both reactions. So you guys will count by doing little dots to show how many atoms of each element you have, both in your reactants and product side for both reactions. You guys will see there's a correct reaction and an incorrect reaction. Okay, circle the reaction that is balanced, aka has the same number of each atoms on the reactant side as the product side. So you guys will see the same number of colored dots on each side. That's the one that's balanced. On each of these, there's one that's, like I said, not balanced, doesn't follow the law of conservation of matter, and there's one that is balanced. So you guys will have to figure out which one is which. All right, so here's your example that I'm going to do for you. Again, at this point, your guys' computers should be facing front. I'm going to go ahead and grab a marker here, and I'm going to change the thickness of that marker so you guys can kind of see my dots well. And then I'm going to choose colors. You guys can choose whatever colors you want when you guys do your 5 examples, but this is my example. So for carbon, I'm going to do pink. For oxygen, I'm going to do yellow. And for hydrogen, I'm going to do, we'll say green. Okay? So since I already have my green marker pulled up, I'm going to go ahead and count how many hydrogens are in each of these. So in this case, I have a coefficient of 2. That means I have 2 CH4 molecules. So it's like writing CH4 twice. Okay? So how many hydrogens do I have in this little set of molecules right here? The answer should be 4. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I meant 8. So 4 plus 4 is 8. So I drew my 8 dots there. Okay? Let's go back and look at what other formulas have hydrogen or what other molecules have hydrogen. So I have hydrogen right there. There's no coefficient in front, so I just have 1 molecule of H2O. So that means I only have 2 hydrogen atoms. So I can tell you guys off the bat here that this one is not balanced. Okay, I have 8 over here, but only 2 over here. That's not right. Okay, where did the other 6 go? Those 6 atoms of hydrogen can't be destroyed. Okay, let's go ahead and do my bottom one. I have a coefficient of 1 in front of this CH4, so I only have 1 molecule of CH4, meaning I have 4 hydrogen atoms. So 1, 2, 3, 4. Okay, on the opposite side, my product side, I have 2 molecules of H2O, so 2 times 2 is 4. 1, 2, 3, 4. Okay, looking right now, my hydrogens are the same for this second reaction. Let's go in and do my carbons. My carbons were pink. So this one I have 2 carbons, 1, 2. And over here I have 2 carbons, 1, 2. So the carbons look good up here. Up here I have 1 carbon, and over here I have 1 carbon. And then on to my oxygen. My oxygen's a little bit trickier. I have 2 oxygens right here, 1, 2. And then I have 4 from this one. 2 times 2 equals 4, so 1, 2, 3, 4. But I have only 1 over here on this one. So I have 5 total oxygens on this side, but only 2 over here. So again, another reason why this first reaction, reaction A, is not correct. Okay, let's check to make sure oxygens are good down here. We have 2 times 2 is 4. 1, 2, 3, 4. And then 2 oxygens right here. 1, 2. And 2 times, we have an imaginary 1 after this oxygen. 2 times 1 is 2. So 2 oxygens right there. Okay, we already know our first reaction is wrong, but let's double check to make sure our second reaction is in fact correct. We should have the same number of colored dots on each side of this. So here's one side, and here's the other side. Okay, so for my green hydrogens, I have 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side. For my carbons, I have 1 over here and 1 over here. And for my oxygens, 1, 2, 3, 4 on my reactant side, and 1, 2, 3, 4 on my oxygen side. So my last step would be to circle the correct equation. Okay, you guys have 5 equations that you are going to do on your own. You guys have, they're fairly simple compared to what we just did This one is the reaction of potassium and iodine to form potassium iodide, which we'll be using when we make elephant toothpaste. Okay, sodium and chlorine coming together to form table salt. Hydrogen and oxygen forming water. The decomposition of hydrogen peroxide, which again, when we do elephant toothpaste, you guys will see this process happen. So H2O2 is hydrogen peroxide. It's that stuff you find in the brown bottle in your medicine cabinet that your mom would yell at you and say, "It's not going to hurt." And then she'd pour it on an open wound and you'd be like, "Ah!" And it would bubble and sting and you'd blow on it to try to get it to go. That's hydrogen peroxide. Okay, so it breaks down to form water and oxygen. And then finally, we have carbon monoxide plus oxygen reacts to form carbon dioxide. All right, so once you guys have those 5 reactions done, you've done all the little accounting by doing all the dots. That is part of your requirement. And then you've circled which correction or which equation is correctly balanced. Then you guys can go ahead and hand this in. You're all done for today, and I hope you are having a great day. Bye.